Okay, so we are moving on to section 5 of chapter 9, which is very much the same as section 4, only instead of talking just about tangent, we're going to talk about sine and cosine. So if you remember, we had this word SOHCAHTOA that was an acronym for our sine, cosine, and tangent ratios. We did TOA in 9.4, which was our tangent, and it was our opposite side over our adjacent side. And today we're going to look at sine and cosine. So sine would be the so part. So sine is going to be opposite over hypotenuse. And then cosine is the part of SOHCAHTOA. So cosine is going to be adjacent over hypotenuse. So we just need to know SOHCAHTOA. If we know SOHCAHTOA, we know how to write sine, cosine, and tangent every time. So we're going to focus on the so and the today. So when we look at our ratios for sine and cosine, it is all dependent upon what angle we're talking about. So they're talking specifically about angle A in this picture. So our opposite side is this green leg, our adjacent side is this blue leg, and remember our hypotenuse is always opposite that right angle. So when we talk about sine is the length of the opposite side over the length of the hypotenuse. I prefer to write it sine equals O over H. For opposite over hypotenuse. Sine is abbreviated SIN, but we aren't going to pronounce it sin because it's not sin. That's just how it's abbreviated. And then cosine is going to be the adjacent leg over the hypotenuse leg. Okay, so sine opposite over hypotenuse, cosine adjacent over hypotenuse. We do those the same way that we did tangent. Now, one other thing that we can do with sine and cosine is complementary angles. So basically what that means is that the sine of angle A is going to be the same thing as cosine of angle B. So where tangent, the ratios just flip-flopped when we looked at the two acute angles, with sine and cosine, they're actually going to flip trig ratios. So the sine of one angle would become the cosine of the other angle. Also, if you needed to know what two trig values might be equal with sine and cosine with an actual degree measure, you use that complementary aspect of it. So if we've got the sine of angle A and we need to change it to cosine, we're going to do 90 minus whatever that angle A is, and it's going to give us the equivalent cosine. So for example, if we needed to rewrite the sine of 30 degrees into cosine, we would just say, okay, well that's going to be cosine of 90 minus 30, or the cosine of 60 degrees. So we're just subtracting that degree measure from 60. Okay, so in number 1, we're going to write sine and cosine for both angles R and angle S. We want to write each answer as a fraction and as a decimal rounded to 4 places. Now, one thing I want you to be careful of in your homework, because for the most part, you all did really well with tangent, but the one thing that I was noticing is that the answer may have been asking for a fraction answer, but a lot of you or some of you were putting decimal answers. So you really want to pay attention to, does it want a decimal or does it want a fraction? So that you don't get marked wrong for something as silly as that. So let's start with angle R. So the sine of angle R. So this angle right here, our opposite side is going to be that 16. Our adjacent side is the 63. That's the leg attached to it. And then that 65 is our hypotenuse because it is opposite that right angle. So the sine of angle R is going to be opposite over hypotenuse. So the opposite side is our 16. Our hypotenuse is 65. You do want to make sure that it will or won't simplify down. If you're not sure, you can do that in your calculator. 16 over 65 does not simplify down. But if we write that as a decimal to 4 places, we're going to get about 0.2462. And then for cosine of angle R, cosine is adjacent over hypotenuse. So our adjacent side is that 63 over our hypotenuse of 65, which also will not simplify down. So when we write that as a fraction, as a decimal, we get 0.9692. So now we're going to look at angle S. So from angle S, our hypotenuse is still our hypotenuse, but that 63 becomes our opposite side, and that 16 becomes our adjacent side. So the sine of angle S, opposite over hypotenuse, becomes 63 over 65, which was 0.9692 as a decimal. And our cosine of angle S, adjacent over hypotenuse, becomes 16 over 65, which was 0.2462 as a decimal. So you notice that the sine of angle R and the cosine of angle S are the same, and sine of angle S and cosine of angle R are the same. So they just flip-flop. So we're doing the same thing in number 2. I would really encourage you to try this one on your own. Pause the video, write your sines and cosines for both of the angles, round it to your decimal 4 places. Make sure if the fraction simplifies that you simplify it, and then come back and check your answers. So I'm going to start with angle D. So from angle D, 7 is my opposite side, 24 is my adjacent side, 25 is my hypotenuse. So opposite over hypotenuse is going to be 7 over 25, which to 4 decimal places is going to be 0.2800. I know it ends at 0.28, but if it asks for 4 decimals, make sure you have 4 decimal places. If you have to add in zeros, that's fine. And then the cosine of angle D, adjacent over hypotenuse, is 24 over 25, or 0.9600 as a decimal. And then if we go to our angle F, 24 becomes our opposite side, 7 becomes our adjacent side, 25 remains as the hypotenuse. So the sine of angle F, opposite over hypotenuse, is 24 over 25, or 0.9600. And cosine of angle F adjacent over hypotenuse is 7 over 25, or 0.2800. Okay, so number 3 is this that second concept I was telling you about, where you can use complementary angles to figure out an equivalent trig function with sine and cosine. So we want to turn cosine of 23 degrees into terms of sine. So in order to do that, we're just going to remember that it all comes down to 90 degrees. So they have to add to 90 degrees together. So when we want to turn cosine of 23 into a sine function, we're just going to do sine of 90 minus 23 degrees, which is going to give us 67. So the equivalent trig function with sine would just be the sine of 67. And if you weren't sure, what you could do is you could type in your calculator sine of 67, hit enter, and then do cosine of 23 and hit enter, and you should get as a decimal about 0.92 for both of those. So you should get the exact same decimal answer if you were to type those into the calculator. That'll work for any sine or cosine value. Okay, so in number 4, we're going to jump into solving for side lengths when we only know maybe one side, and so we can't do Pythagorean theorem or use special right triangles. So we have an angle of 65 degrees. 8 is our hypotenuse. T is opposite that angle, so it's our opposite side. U is connected to that angle, so it's our adjacent side. We want to solve for U and T. So if we solve for U first, it's our adjacent side, and we know our hypotenuse. So you have to use the side you know. So adjacent and hypotenuse is our cosine function. So we would say the cosine of 65 degrees, just like we did with tangent, only we're using sine or cosine now. So cosine of 65 degrees is our adjacent side of U over 8. So remember, to get U by itself, we're just multiplying both sides by 8. So again, I would encourage you to do 8 first times cosine of 65 in your calculator. That way you don't accidentally multiply the 8 and the 65 together. So 8 times cosine of 65, which should give you a U value of about 3.38. Oh, sorry, it wants to the nearest tenth. So if we round that to the nearest tenth, 3.38 becomes 3.4. So we solve for U, now we have to solve for T. One thing I would encourage you is to not use a rounded answer to solve for another variable unless you absolutely have to. So when we solve for T, use T and then that side that we're given of 8. So our opposite side in our hypotenuse is going to be sine. So the sine of 65 degrees equals that opposite side T over our hypotenuse of 8. We're going to multiply both sides by 8 again to get T by itself. And in your calculator, 8 times sine of 65 degrees to the nearest tenth is going to give us about 7.34 T. Again, just a reminder when you're doing your homework on big ideas, make sure you're rounding to whatever decimal place it wants, because if you don't, it will mark it wrong. Also, make sure you're rounding correctly. So if you're rounding to the nearest tenth, you're going to go to that 100th place, that second spot in our decimal. If it's 5 or higher, you're going to round it up. If it's 4 or lower, you're going to leave it the same. So make sure you're rounding correctly, because again, A lot of points were missed because you guys weren't rounding correctly on your 9.4 homework. Okay, so these are going to feel harder than they really are, but we're going to combine special right triangles with these trig functions. So when it says find sine and cosine of a 60-degree angle, what you're going to do is you're going to draw a triangle, and you're going to turn it into a 30, 60, 90 triangle, because if one of your angles in your right triangle has to be 60 degrees, the other acute angle has to be 30. And we're just going to make this as simple as we can. So we're just going to say, all right, our short leg is going to be 1, which means our hypotenuse is always 2 times our short leg. So that hypotenuse is going to be 2. And our long leg is always our short leg times the square root of 3. So 1 square root 3, or you can just write it as square root 3. So from that 60-degree angle, which is up here in my picture, 2 is our hypotenuse, 1 is our short leg, or our one is our short leg, which is also the adjacent side to that 60-degree angle, and square root 3 is the long leg, which is also the opposite side of that right triangle. So sine of that 60-degree angle is going to be opposite over hypotenuse. Opposite side, square root 3 over hypotenuse of 2. That doesn't simplify anymore, so we leave it as that. For cosine, we're doing the same thing. Cosine of this 60-degree angle is our adjacent side over our hypotenuse. So our adjacent side was 1. Our hypotenuse was 2. So we have a cosine of 1/2. Now, some of you might be thinking, well, where did you get the 1, 2, and square root 3? Well, I picked any number I wanted for my short leg because it doesn't matter. You could pick 2, 3, 4, 100. It doesn't matter because you're still going to use special right triangles to find your long leg and your hypotenuse. And your hypotenuse is always going to be 2 times whatever your short leg was. Your long leg is always going to be your short leg times the square root of 3. So that does not matter. So when you write those as a ratio, when you write those as a fraction, it's always going to simplify down to square root 3 over 2 for your opposite and your hypotenuse. And it's always going to simplify down to 1/2 for that adjacent in your hypotenuse from your 60-degree angle. Hopefully that answered questions of where I got those numbers from. If you're still not sure, either jump on Zoom or shoot me an email before the end, like before you finish all of this, before you're done with your schoolwork for the day. So in number 6, we're doing the exact same thing, but we're doing it with a 45-degree angle. So we're going to draw our right triangle, but this time it's going to have a 45-degree angle, which means our other acute angle is going to be a 45-degree angle. So remember that 45, 45, 90, the legs are always the same. So it does not matter what you pick for those legs to have a length of. I'm picking 1 because it's the easiest thing. You can pick 2, you can pick 10, you can pick 100. I do not care. It does not matter. You'll get the exact same answers for sine and cosine either way. So to find our hypotenuse in a 45, 45, 90, it's your leg times the square root of 2. So 1 times the square root of 2 is just square root 2. So for sine and cosine of that 45-degree angle, it doesn't matter which 45-degree angle you pick. I'm just going to use the top one. So my opposite side is this bottom leg. My adjacent side is the leg on the left. And then that square root 2 is my hypotenuse. So sine of 45 degrees, opposite over hypotenuse, becomes 1 over square root 2. But what we do not like with fractions is square roots to be in the denominator. So we're going to multiply by square root 2 over square root 2. We're going to rationalize. So 1 times square root 2 is square root 2. Square root 2 times square root 2 is the square root of 4, which is just 2. So sine of 45 is going to be square root 2 over 2. Now cosine of 45 is our adjacent side over the hypotenuse. Well, our adjacent side is 1. Our hypotenuse is square root 2. So it's the same thing that we had for sine. We still have to rationalize that. So we're multiplying by square root 2 over square root 2. And when we simplify that down, we're going to get square root 2 over 2. So with 45, 90 triangles, sine and cosine are always the same. And they're always square root 2 over 2. Okay, last thing for this section. In 9.4, we talked about angles of elevation. Those were angles that went up. Angles of depression are angles that go down. So the thing about it, though, is it has to be the angle formed with a horizontal line. So if you're going to have an angle of depression, that angle of depression is this angle in here. So it's the angle connected to that horizontal line, but it's going down. Okay, so it's that angle in between. So when we look at number 7, you're skiing on a mountain with an altitude of 1,200 feet. So altitude meaning how high you are. The angle of depression is 21 degrees. Find the distance x that you ski down the mountain to the nearest foot. So we're going down this mountain. This is what we need to find the length of. We're 1,200 feet up. So they labeled this side as 1,200 feet. We could have also labeled this other side. They're going to be the same. But the reason they labeled it on the right side is because we've got an angle of depression. So that angle of depression has to be formed with that horizontal line. So it's going to be this angle up here, that 21 degrees. So from that 21 degrees, your 1,200 is your opposite side. Your x is your hypotenuse. Hopefully you're realizing that opposite and hypotenuse, we're going to have to use sine. So the sine of that 21 degrees equals our opposite side of 1,200 over our hypotenuse of x. So we need to get x out of the denominator. So we're going to multiply both sides by x. And then to get x by itself, we're going to divide 1,200 and the sine of 21. So in your calculator, 1,200 divided by sine of 21, close your parentheses. To the nearest foot, we skied 3,349 feet. Okay, so your homework will be ready to go on Big Ideas after you finish taking your notes. If you have questions, let me know.